In this video, we are going to determine whether or not the vectors v and w are equal. Now I've labeled the vector v, you can see here, and the vector w you can see here. And I've also labeled the point P with its given point, Q, R, etc. And so now remember, two vectors are equal when they have the same magnitude and direction, when they have the same length and direction. Remember, magnitude is the length of the vector. So when I say magnitude of v, I mean how long this line is. When I say magnitude of w, I mean how long this line is. All right, so let's figure out the length or magnitude of w. Let's figure out how long that line is. Now the thing to notice is that we can form a right triangle here. Oops. Maybe not quite a right triangle there as I've drawn it. Let me try and draw it better. We can make a right triangle there. And now replacing that w, I'll just put a little c here, an a there and a b there. Aha, it's a right triangle with legs a and b and hypotenuse c. So we know that a squared plus b squared equals c squared. That's the Pythagorean theorem. So how long is a, right? Well, this is the point 4, 2, right? So a equals 4 and b equals 2. So we have 4 squared plus 2 squared equals c squared. Let's see, that's 16 plus 4. So 20 equals c squared. And so c is the square root of 20. Now remember, that's the length of that there, and just as a name, we call, so let's see, maybe I'll put that c back in there. Just as a name, we call this vector w, vector w. So I'll put this little w here to indicate that that's what we call the vector, right? And this vector, how long is this vector? The magnitude or length of w is c, which we found to be root 20. All right, now let's do the same thing for vector v. We can make another right triangle right here. Call this A, call this B. Let's rename that, so I'm not renaming, right? I want to emphasize that this is not C. C is a length, V is a vector. A vector is two things. A vector is a length and a direction. So I'm just going to, when I make this into a triangle here, I can say that length is c, and we know that a squared plus b squared equals c squared. Now how long is a there? Let's see. That's an x distance. We start at x equals -1, and we end at x equals 3. So let's see, if you start at -1 and you go over to 0, that's 1, and then 1 plus 3, that's 4. So a is going to be 4. Another way to write that is 3 minus a -1 squared. That's another way to get that distance a. Another way to get the distance b, so the distance b, we're starting at 2 and we're ending at 4, so you can see that's a 2. Another way to get that, 4 minus 2 squared equals c squared. Doing the math, let's see, what is that? That's going to give you a 4 squared plus 2 squared equals c squared. All right, and as we already saw, that's 20 So C is root 20 again. So that tells us that the vector V has length root 20. So they have the same magnitude. Now we have to ask, do they have the same direction? Now, for the purposes of this class, because we're in Calc 2 and our motivation in Calc 2 to teach, or for teaching you vectors, is to get you ready for Calc 3. In Calc 3, you work in 3 or more dimensions. And the way that you'll be able to tell if two vectors have the same direction in Calc 3 is you'll look at these angles here. You'll look at this angle, theta 1. You'll look at this angle, theta 2. And you'll say they have the same direction if theta 1 equals theta 2. And the way you'll find that is using trigonometry. Now, for the purposes of this class, because we are working only in 2 dimensions, and I want to stress that because we're only working in 2 dimensions, we can tell if they have the same direction by looking at the slope. So what is the slope of the line segment PQ? So let's see. Of the line, so slope of the line PQ. Right, remember this formula, y2 minus y1, x2 minus x1. So the slope of this line here, right, let's see, what is y2? What is y1? So you have 4 minus 2 over 3 minus a negative 1. That's 2 over 4, which is a half. Now let's look at the slope of the line segment OR. Again, y2 minus y1, x2 minus x1. In this case, we have 2 minus 0 over 4 minus 0, which again is a half. Now, there's another piece to tell if they have the same direction. In our special case of working in only 2 dimensions, x and y here. And that is that they both, that these arrows are both pointing the same direction as well, right? So they're both angling up and right. If it were the case that instead the initial point of V was there, and it went like that, then we could see immediately that they don't point in the same direction, because this one goes that way, that one goes that way. But that's not the case, right? They both go in the same general direction that way, and their slopes are equal. Right? So in fact, V and W have the same magnitude, root 20, and they have the same slope. And they both point like so. So we would say that yes, V and W are equal. They are the same vector. They represent the same